Hello students, when I was explaining the concept of adsorption, I told you that when adsorbent molecule gets attracted to adsorbate, during that time there some forces are involved and these forces can be either weak or strong. Depending on the forces are either weak or strong, we have two types of adsorption. Where weak forces are developed, there we call physical adsorption, and where the strong bond is developed, there we call as chemical adsorption. So in today's video we are going to discuss physical adsorption and chemical adsorption in detail. So let us study the first type of adsorption, physical adsorption, commonly called as Physisorption. When Physisorption occurs, when the force of attraction between what? Between adsorbent and adsorbate, they are weak forces. And in 11th class basics we have studied the types of weak forces. These are van der Waals forces. So when the force of attraction between the adsorbent and adsorbate is weak van der Waals forces, that time we say the type of adsorption is Physisorption. Now these weak van der Waals forces, these are responsible for some special characteristics of Physisorption. So we'll study all these characteristics one by one. The first characteristic is low enthalpy of adsorption. Basically, what do you mean by enthalpy of adsorption? When 1 mole of adsorbent gets attracted to adsorbate, whatever energy is released during that time, that is called as low enthalpy of adsorption. Now, since in case of Physisorption, the force of attraction, it is a weak. And which kind of attraction it is? What type of forces are developed? These are van der Waals forces. Since their force of attraction, they are very weak, therefore enthalpy of adsorption for Physisorption is also very low. Generally, it lies in the range of 20 to 40 kilojoule mole inverse. Now here every characteristic can be a give reason question. For example, in this characteristic question can be asked, why Physisorption have low enthalpy of adsorption? Physisorption, they are reversible in nature. Now the question is, why Physisorption is reversible in nature? The answer lies again here. Because of weak force of attraction. Always you have to remember this word, van der Waals forces. Now since these forces between adsorbent and adsorbate, they are very weak, these can be easily reversed. Either by increasing temperature or by decreasing pressure. Always you have to remember that the gases, they get adsorbed on solid. Like carbon dioxide gas get adsorbed on platinum, hydrogen gas gets adsorbed on nickel, etc. So it is always a gas gets adsorbed on the solid. It's a reversible. Now according to Le-Chatelier principle, Le-Chatelier principle we have already studied in class 11th. If we increase the pressure, what will be the effect on the equilibrium? The equilibrium shifts towards forward direction. That means more and more adsorption will take place. Similarly, if we decrease the pressure, the equilibrium will shift backside. And therefore we say Physisorption is reversible in nature. Now once this concept is clear that solid always act as adsorbent and gas always act as adsorbate, we will move to the next characteristics of Physisorption. The next characteristic is effect of temperature, and that's a very important question. It is a frequently asked give reason question. So first of all, let us try to understand what is the effect of temperature. We know that adsorption process is exothermic. We have seen its del G is negative, and therefore according to Le-Chatelier principle, if we decrease the temperature, the equilibrium will be shifted in forward direction. That means the Physisorption is favorable at low temperature. What will be the effect if we increase the temperature? Okay, so what will happen at high temperature? At high temperature, since we are increasing the temperature, kinetic energy of the particle increases. Now as the kinetic energy of adsorbate particle increases, what will happen? They will leave the surface of adsorbent more rapidly. And therefore at high temperature the adsorption, its rate decreases. Therefore we say at high temperature the Physisorption is not a favorable one. Physisorption will be favorable or will occur readily at low temperature. Moving on to next characteristic. For understanding the next characteristic, again we have to look the force of attraction between adsorbent and adsorbate. The force of attraction in case of Physisorption is which one? Weak van der Waals forces. And therefore what happens? There is no specificity for which gas will get adsorbed on which kind of solid. And therefore we'll say Physisorption is not specific in nature. For knowing the next characteristic, we have to know the nature of adsorbate. What is the adsorbate? Adsorbates are generally gases, and these gases, when they get adsorbed on the solid, we have to consider their critical temperature. So considering these 2 points, I can say the gases that get easily liquefiable, or I will say the gases which have high critical temperature gets adsorbed easily. Again, the reason lies in the fact that weak van der Waals forces. Weak van der Waals forces, when they are very strong, they are strong near critical temperature. So those which have high critical temperature, their van der Waals forces will be developed very strongly, and therefore they get adsorbed quickly. For example, SO2, its critical temperature is 673 Kelvin. Methane, its critical temperature is 190 Kelvin. And dihydrogen gas, its critical temperature is 33 Kelvin. Okay, now using this concept, tell me the answer. Out of sulfur dioxide, methane and hydrogen, which gas will get adsorbed very quickly? As the critical temperature indicates, sulfur dioxide will get adsorbed very quickly. Or I will say sulfur dioxide will be readily adsorbed. The next characteristic we have already studied at the starting of the chapter. Physisorption is dependent on surface area. More the surface area, more will be the adsorption. And that's why most of the catalysts, they are divided finely so that the more and more adsorption can take place. If the adsorbent has less surface area, then the adsorption will not take place to the greater extent. I will give you one example. Like the lump of Bonvita, during rainy days, the Bonvita gets converted to lump. So that do not get dissolved in milk quickly. On the other hand, Bonvita, when it is in powdered form, it gets dissolved in milk very quickly. And therefore, we say Physisorption. Or why that has happened? Because the surface area in the powdery form increases. And therefore, I will say the catalysts, generally, they are finely divided substances. Next characteristic is multimolecular layer. Now, since Physisorption involves development of weak van der Waals forces, if I have this adsorbent with me, any one particular one, and on that there can be multimolecular layers can be developed. Sorry, I will say adsorbed. As the Physisorption process do not involve any strong force of attraction. For example, at 83 Kelvin, nitrogen is adsorbed on iron in the form of molecule. That is, it gets adsorbed in the form of N2. Now, what happens when we increase the temperature? That will be studying in Chemisorption. Now, let us study the graph for Physisorption. Suppose I plot a graph of X by M versus temperature, where X is the amount of gas adsorbed, M is the mass of adsorbent, and T is the temperature. So we have seen as the temperature increases, the Physisorption decreases. So this is the graph of Physisorption. Now all these characteristics we will study for Chemisorption also, and then we'll find out the similarity between Physisorption and Chemisorption. So let us begin with the next type of adsorption, chemical adsorption or Chemisorption. During Chemisorption, the adsorbents are held on the surface of adsorbent by strong chemical bonds. This is how Chemisorption differs from Physisorption, and therefore characteristics of Chemisorption becomes totally opposite to that of Physisorption. For example, the first one, low enthalpy of adsorption. In Physisorption, it was very high, very low. And in case of Chemisorption, it has high adsorption enthalpy because of strong chemical bond formation. Now suppose I want to have the value of enthalpy of adsorption. It lies in the range of 80 to 240 kilojoule mole inverse. Reversibility. Unlike Physisorption, Chemisorption is irreversible in nature. Why? Because once the bonds are formed, they cannot be broken. Most of the give reason questions are based on this concepts only. So in case of Physisorption, you have to remember weak van der Waals forces, and in case of Chemisorption, you have to remember the strong chemical bond. Okay. Now effect of temperature. For Chemisorption, the increase in temperature, Chemisorption first increases and then decreases rapidly. In Physisorption, we have seen low temperature favors, whereas in case of Chemisorption, high temperature favors Chemisorption. Now, when we discuss the concept like specificity for Chemisorption, we know that the Chemisorption requires or Chemisorption involves bond formation, and therefore Chemisorption is highly specific in nature. Remember student, each and every point here is a give reason question. Now what do you mean by here highly specific? Suppose I want to adsorb oxygen on the metal. Oxygen will be adsorbed on the metal surface by virtue of oxide formation. Whereas if I want to adsorb hydrogen on the metal surface, then it gets adsorbed by virtue of hydride formation. So this is how chemisorption becomes very specific in nature. Now nature of adsorbent. Again it is the same that of physisorption, that gases that get easily liquefiable or the gases that get easily liquefied, or I will say with higher critical temperature, get adsorbed readily. When we come to surface area, even chemisorption is dependent on surface area. So these 2 points, nature of adsorbent and surface area, these 2 points is a point of similarity between physisorption and chemisorption. So many times this question is asked, give one point of similarity between physisorption and chemisorption. The last characteristic of chemisorption, it is monomolecular layer formation. Like in physisorption we have seen it forms multimolecular layer, but in case of chemisorption we know there is a bond formation, and since it's a bond formation, only a single layer can be developed. Like at 773 Kelvin, nitrogen gets adsorbed on iron as nitrogen atom, whereas in case of physisorption we have seen at 83 Kelvin, nitrogen gets adsorbed as nitrogen molecule. So we have lots of point of difference between physisorption and chemisorption. These points are asked as a direct question, either a general question or with respect to specific characteristic. Now if I want to plot a graph of how much adsorbent can be adsorbed at a particular temperature, that is graph of x by m against temperature, we have seen that as the temperature increases, chemisorption first increases and then decreases. So this is the graph for chemisorption. Now when we have studied the concept of physisorption and chemisorption, we came to know that various gases gets adsorbed on metal surface, but different gases gets adsorbed on different metals in different amount. Some gases get adsorbed in more amount, some gases have particular specificity for a metal. So what is the relation between the gases and the solids, that is the amount of substance adsorbed by adsorbent and equilibrium gas pressure at constant temperature is given by the term adsorption isotherm. Now why we need to develop adsorption isotherm? To know how much amount of the gas will get adsorbed on the metal at a particular pressure at a particular temperature. So here I am taking the example of nitrogen gas. Okay, so we'll be studying variation of nitrogen adsorbed on charcoal with pressure and at constant temperature. So we will be studying the example of nitrogen adsorbed on charcoal with pressure at constant temperature, or I will say we will study the adsorption isotherm for nitrogen. So this graph is for adsorption of nitrogen on charcoal at 273 Kelvin at 244 Kelvin and at 193 Kelvin. 195 Kelvin. So as we can see from the graph, as the temperature decreases, the amount of gas getting adsorbed increases. Various scientists have tried to explain adsorption isotherm in various ways, but the most successful explanation was given by Friendlich. So now we will study Friendlich adsorption isotherm. Friendlich says that x by m is directly proportional to p raised to 1 by n, where x, m and p, that terms we have already seen, like x is the amount of gas getting adsorbed, m is the mass of adsorbent, P is the pressure, and N can be constant and it will have value greater than 1. So x by m is directly proportional to P 1 by m, or I will say x by m equals to K into P 1 by n, where K will be constant. Now the values of N and K, these constant, these values depends on nature of adsorbent and adsorbate. Okay, now coming back to this equation, we will take log of both sides. Taking log on both sides, what will get the equation? We will get the equation log x by m equals to log k plus 1 by n log p. This equation is asked as a direct question in your 12th board exam. Although you don't have any numericals based on this, but they ask you this equation. Write the expression for Friendlich's adsorption isotherm. Now this equation log x by m equals to log k plus 1 by n log p. We will try to plot the graph for this equation. So when we plot the graph of log x by m against log p, it gives a straight line. The slope of this graph gives us 1 by n. And if we continue this graph, if we extrapolate the graph on log x by m axis, then this intercept on log x by m axis gives us the value of log k. So this whole graph explains the equation log x by m equals to log k plus 1 by n log p. Now we have to study these at different pressures. Let us study what happens at low pressure. At low pressure, the graph is almost a straight line. Indicating that x by m is directly proportional to P. Whereas at high pressure, the graph becomes almost constant. That means the line will be parallel to the x-axis. The line will be parallel to log P. So at high pressure what happens? We can say x by m gets independent of pressure. So now can you predict which pressure will be favorable for explaining Friendlich's adsorption isotherm? Obviously low pressure. And this is the limitation of Friendlich's adsorption isotherm, that it fails at high pressure, because at high pressure the ratio x by m becomes independent of pressure. So this limitation of Friendlich's adsorption isotherm, generally it is asked for 1 mark question. So in today's video we have discussed about Physisorption chemisorption, their characteristic, and we have studied about Friendly's adsorption isotherm. Based on today's module, I am giving you some questions that you will try to solve on your own. So these are the homework questions for today's video. As I have already told you, from Physisorption and Chemisorption topic, the differences question, the similarity question, difference with respect to a particular characteristic can be asked, a general definition, general differences can be asked. Then for Friendly's adsorption isotherm, this is the most famous question, its equation can be asked. So these way different questions can be framed from this topic. That's all for the day. Thanks for watching. Have a nice day.